Assalamualaikum and greetings, Doctor. My name is Nur Nada binti Mazlan with a matrix number of CA200002. So today I'll be presenting to you on question 1. So for question 1A, we were asked to compute the multiple integrals of this equation. So this is my manual calculation where to integrate we need to follow the sequence, which is the x, dy and dz. So my calculation step leads me to a final answer of 203.120. For question 1A, I use Maple software. This is the code, and then insert the final step and press enter. We got a final answer of 203.120, same as our manual calculation. So moving on to question 2, we need to solve this equation according to the following limitations. So this is my manual calculation where we integrate the dy dx and have a final answer of 25.3333. For question A2, I use MATLAB software. So these are the codings. Click run section and you could see the answer in the command window, which is the same as our manual calculation. Next we have question B, where we need to evaluate the following triple integral by using spherical coordinate. So this is my manual calculation with a final answer of 24576 pi per 5. So for question B, I use Maple software. So this is the spherical and this is our cone. And this is our final answer, which is the exact same as our manual calculation. Next, we have question C1. So this is my manual calculation with a final answer of 5.8905 units square. So using MATLAB software, click on the question C1 section and then run section. And you could see the final answer on the command window is the same as our manual calculation. Last but not least, question C2. By using double integrals, find the area of region enclosed by this equation. So these are my manual calculation, which has a final answer of negative 0.4142, and this is the MATLAB simulation, where we also get a final answer of negative 0.4142. That will be all from me.
My name is Nur Shafika binti Ismadi, and I will be doing the question 2, the demonstration of question 2 for this assignment. So the first one is the question 2A1. We use this coding. I learned how to do this coding from YouTube. So the first thing is we use CLC and clear all to clear all the results and all the variables that we've used so that there won't be any disruption in obtaining the result. So first we run this section, and this is the result that we are going to get in the command window. As I observe, so far I obtained the same result as I get for the calculation in our reports. So the second one is the question 2A2. This is the answer that we will get. And for question B, this is for this one, and this B is for this. So there will be two different answers for the same question, which is question 2B. For question 2C, we'll get this. So B plus D, this is the answer, 0. Meanwhile, the answer for A is this one, the answer for B is this one, C, and D. And the next one is the question 2D1. As we can see the final answer here, this will be the answer for dx over dz, and this will be the answer for dy over dz. And the next one is the D2. We run section, and same like previous one, this one is the answer for dz over dx, and this one is the answer for dz over dy.
Wabarakatuh. My name is Nur Adawi binti Rauf. My matrix number is DE 2063. I'm going to present my part for question 3. Okay, for the first one is question A. We have to find the divergence of curl, where usually it's supposed to be 0. So as our manual calculation, we got 0. So we have to find the answer by in the simulation. I'm using the MATLAB software. So as we run the code, we got 0, same as our manual calculation. So for B, question B, we have to find the first one, the first column here. We have to find is the code for we need to know whether the force is conservative or not. And the second part column here is for to check the work done, as you can see here. So all you need to do is just run the codes. Okay, so in the command window you can see that F is conservative force and lambda is negative pi power of 3, and lambda is actually represent the work done. Okay, so as you can see, we just need chicken we have to find the integration of the F, and then we just need to find the work done, which we substitute the integration that we got before with the xy with the value that we want to substitute, and then the answer we will get negative pi power of 3. Okay, so for the C, the last one, I use symbollab.com. It's actually a calculus calculator, on a calculator where it will show you step by step of a calculation. So after I put the equation that we want, the question that we want, and then just go and you will find the answer. We will get the answer, which is this square root 243 pi plus 729 pi over 2. Okay, you can see the step by step, but it's actually a premium one, so I don't have a premium account. So the last one, you just can see the answer here, the answer. Okay, I think that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum and hi. My name is Muhammad Razman. My number is DE20069. So we'll continue for the question 4B. So the first question is to sketch the graph of the surface. The surface that we need to sketch is cylinder where the equation is x power of 2 plus y power of 2 equal to 4, where z is equal to 4 and z is equal to 0. So the second surface is cone, which is the equation is x equal to square root x power of 2 plus y power of 2. So we put all this equation inside the simulation software. So the simulation software that we use is Maple 2021, and these are the equation that we obtained from the question. So these are the graph of the surfaces where z is equal to 0 and z is equal to 4. These are for the cone, and this one are for the cylinders. So let's take a look for the second question, which is to find the divergence of vector field in bracket x, y, z, where this equation we obtain from here, where yi plus xyg plus bzk. So the manual calculation that we do, we get this answer, which x plus with 1. That are the divergence of the vector field. So let's take a look on the simulation software. These are the coding for the question 2 and question 3. Where from here to here are for the question 2, and the last one is for the question 3. So the vector, first we set the coordinate Cartesian x, y, z, and then we call vector field where yi plus xyg plus zk, and then we do this coding divergent in bracket f, and then we get the answer is 1 plus with x. So the answer for the manual calculation and the software are same. So let's take a look for the last question, which is use the Gauss theorem to evaluate the flux of the vector field x, y, z across the surface. The manual calculation we get is 2 pi divided by 3. So I think it's better to look at the manual calculation first, and then we go with the simulation. So these are the manual calculation for the question 3, which is for Gauss theorem. Inside this theorem, there's a left hand side, right hand side. So based on this manual calculation, we use the left hand side, where the range of z is 0 to 4, r is 4 to r, pi angle is 0 to 2 pi. We put all this value inside the integral, and then we get integral to 0 to pi 0 and 4r. These are the value for divergence, and then we convert it to the cylindrical coordinate, where we get the r cos theta plus 1, and then we do all the manual calculation, and then we got the value for flux is 3 to pi divided by 3. So these are the final value for the flux, and then we see on the simulation. So inside the simulation, these are the code for the flux. We put the exact equation from here inside the simulation, and then we got the value for flux is 3 to pi divided by 3. So that's all for me. Thank you.
Okay, Assalamualaikum. My name is Muhammad Hafiz bin Abdullah. My matrix number is DE 2080. So today I will explain how to answer question 4C. This is the vector field oriented given, and we need to sketch the surface. So this is how I sketch the surface. 0 with the coordinate given. This one, and this is the proof of I'm using GeoGebra to make a graph like this. For question 4C2, we need to evaluate the vector field by using C-stroke theorem. So this is my work on how I answer the question. So first, we know that the flux field dr equal to delta times F and ds. So delta times F is equal to curl F. So turn it into the matrix form and we get this one. And you need normal vector over the surface S, this one, and we get this. Then we derive it until we get ds over dA over n times k, and we get 3dA. A is equal to x, y, 0, less than x, less than 1. So delta times f times n equal to zi plus yk, and then we get y plus z over 3 is 3 over the surface S. X plus y plus z equal to 1, and y plus z is equal to 1 minus x. So then we get delta times fn equal to 1 minus x over square root 3. Then integration of fdr is equal to delta times fds and delta times f and ds. So we derive it, we solve it, and we will get the answer 1 over 3. So by stroke theorem, fdr is over 1 over 3. So this is the proof of the answer.